General relativity, step by step. I've been trying to evaluate this expression here, which is a statement of conservation of mass energy in our trial metric here for the universe with the cosmological fluid. And my life has suddenly become a lot easier, because although the Christoffel symbols are non-zero, they're all of this rather simple form here, a dot over a, and in particular they're all the same. So that means that I can evaluate this expression here much more easily than one might expect. So let me just do that. I'll go over here. So the thing I'm going to use is that all the non-zero Christoffel symbols, certainly all the ones I need, are a dot over a. So let's have a think about this. Let's write that here. We've got di t t t by di t, a lot of t's in that, plus. Now then, how best to do this? Well, I'm just going to factorise out a dot over a times 1, 2, 3. We've got 3 stress energy tensors with T upstairs and downstairs, which is that one there, minus a dot over a times TRR plus T theta theta plus T phi phi, and this whole thing equals 0. Right, well, that's making things a lot easier. And now what I'm going to do is I'm going to remind you from screencast, I can't remember what it was, let's have a look. What I want to do is to find the stress energy tensor components with one upstairs and one downstairs index, and I'm flicking back through our previous screencasts. I probably won't be able to find it. It was quite a long time ago. There's all this Q stuff here. There are the field equations. There are the field equations. Oh, here we go, here we go, here we go, here we go, here we go. So this one here is the stress energy scalar, which is this expression here. Actually, I'm going to get rid of that c to the power 4. That crept in there, and that shouldn't be there. I'm using units here in which c equals 1. If you use units in which c is not equal to 1, you get all sorts of confusions. So this is a misleading term here. Let me just pinch in on that and get rid of it. Of course, OneNote won't let me do that. Okay, so let me just talk about what we've got here. We've got a stress energy scalar, which is this term here. And we've got the stress energy, the components of the stress energy tensor with one upstairs and one downstairs index, which are this term for the T00 term, and for the spatial components we've got P0 minus lambda upon 8 pi g. Right, well, let me go back to where I was, and we'll stick those components in and see what happens to my... Right, so let's just have a look at this. We've got di by di t of minus rho 0, that's this term here, minus gamma upon 8 pi g, oops, that should be a square bracket, plus 3 a dot over a times the same thing, minus rho 0 minus gamma lambda, I'm sorry, over 8 pi g, minus 3a dot over a. It's 3 because all these components are the same thing, and each one is equal to P0 minus cosmological constant upon 8 pi capital G, and this whole thing is equal to 0. Right, now we're talking. Various things are going to cancel here, and so I'm going to cancel them while I can. So I'm going to use my red pen. That is equal to 0 because the cosmological constant by construction is a constant. It's quite a profound statement, that. The cosmological constant is a constant, and so it is just a particular value across the whole of space-time by construction. And this term, of course, cancels out with that term there. Well, that's nice. So what have we got left now? Let's just go in a little bit more. We've got minus di rho 0 by di t minus, from this term here, 3 a dot over a rho 0 minus 3a dot over a p0 equals 0. And all the cosmological terms have cancelled out. What I'm going to do now is multiply by a cubed. Actually minus a cubed, because I want to change the sign. So we've got a cubed di rho by di t plus 3 a dot a squared, oh no, that's just a rho, plus 3 a dot a squared p0 equals 0. Now I'm going to observe that that equals di by di t of a cubed rho 0 plus p0 di a cubed by di t equals 0. And that is our equation of state for the cosmological fluid using the coordinate system that we have chosen. In particular, r is a co-moving distance, a co-moving radius. I'm going to stop here. I don't like these screencasts getting too long, and there's been quite a lot going on here, and I'm worried that I'm going to cock something up and spoil it. And so I just want to leave that formula there, and I'm going to talk about it in the next screencast. Stop.